The Earth has always gone through periods of warming and cooling, but right now the Earth is going through a period of warming that's faster than ever. So, how do we explain and predict climate change? So, the current period of global warming is only one example of climate change in the Earth's entire history. We don't know for sure what always causes change in the climate, but some theories include continental movement, the global conveyor belt moving water around the Earth's surface, and the theory of wobbly Earth. So, plate tectonics are random, and the North American plate and other continents have been in many positions over the history of the Earth. But evidence has shown that glaciation only occurs when large land masses, so continents or large countries, are near the poles. As the continental ice sheets begin to form, the snow and ice reflect the sun's rays back into space, and the entire planet experiences a global cooling period. So, when continents are near to the poles and become covered with ice, this cools the entire continent down, entire globe down. Also, a global conveyor, which you can recall from Science 10. So, water has a very high specific heat capacity, which means coastal areas like Vancouver have a more temperate climate than Edmonton, where temperature can fluctuate between minus 40 in the winter and plus 35 in the summer. Now, a huge volume of ocean water is capable of transferring a tremendous amount of heat from the equators towards the poles. Now, when we talked about the convection currents in the rock cycles, this happens similarly in the water. And the oceans have giant convection currents that transport heat in a similar way. The global conveyor is the system of the ocean currents that circulate warm water from the tropics towards the poles and cool water from the poles towards the ocean. And this moves not only heat, but nutrients around as well. So many European cities are warmer than the Canadian cities at a similar latitude because warm water from the equator moves up towards the coast of Europe. Antarctica has its own ocean current that recirculates the cold water around the entire continent, which explains why it's the coldest place on the planet. Now, if the glaciers in Antarctica melt, there would be a significant rise in the water level of the oceans, and many parts of the world would experience major floodings. So, an increase in carbon dioxide emissions could cause the ocean conveyor to weaken or reverse. Now, if we had an increase in CO2 emissions and air temperatures rose and more water entered the ocean, we would have a dramatic increase of cold water being put into the Arctic and Antarctic currents, which would cool down. Which could cool down the entire ocean currents, the ocean cycles, causing that conveyor belt to stop or slow down. So, the theory of wobbly Earth. So, this is just showing where the North Pole has been, magnetic North Pole has been geographically over the last several decades. So the Earth actually orbits in three different ways. So it can vary in three different ways. The shape of the orbit is the ellipse, is the closer to a perfect circle, the tilt of the axis of rotation, and the wobble on the axis of rotation, which means every once in a while, all three factors combine to make the part of the Earth at maximum possible distance from the sun. And these points typically coincide with the timing of the Pleistocene glaciations. So when there is less solar energy reaching the Earth due to the shape of the orbit and the wobble of the rotation and the tilt of the axis. The Earth is receiving less solar energy, which contributes to a cooling and glaciation period. So while our sun doesn't show any signs of giving up its solar energy contribution anytime soon, it does not always shine with the same intensity. So though the variations in output are small, so 0.1 or 0.2%, there is a correlation between a low frequency of sunspots, indicating additional solar energy being released during particularly cold periods of human history, like the medieval Ice Age from 1645 to 1715. So over this half century, there was a decline in the release of sunspots, and it contributed to a cooling of Europe. So what's the big deal then about global warming? So if the Earth has experienced global warming and cooling throughout history, what's the concern with global warming now? It is a part of our natural planet cycles, but the concern is the degree of change, so how much it's changing, and the rapidity of change, how fast it's changing. And this is a concern because we rely on crops and domestic animals to feed our population. And if we're not able to grow the produce and crops that we were able to before, then this is going to affect the success of human life on Earth. And so the concern is not only for human health and ocean levels, but also for the ability of the human species to feed itself.